Okay, so our last screencast is going to be on energy conservation. And this picture, I think, says it all. Basically, the idea is if I can improve the efficiency by conserving energy of a system, then I can reduce the amount of wasted energy and therefore the amount of carbon dioxide I'm producing. I can extend the amount of time that my energy reserves will last. So conservation is the best weapon we have in which to avoid the calamity that I talked about with the end of coal, oil, and natural gas. So if you look at these graphs, you see that peak gasoline is here, peak natural gas is soon, peak coal is that is going to quickly drop off after that. Now, what we can do is by using less energy now, we can flatten these curves out and extend them vastly. And if we can change the shape of these curves through conservation, then we can have the breathing space we need, no pun intended, in which to develop other long lasting forms of energy, uh, which we've talked about before. So how do we go about doing this? Well, conservation comes down to three basic things. So there is changing your personal habits, something that you can do personally to help the problem. You can have investment in new technologies that help us conserve without even trying. And then you can have a concept called cogeneration, which is actually a biggie. I mean, so that the best savings we can make is through that. So let's just take a look at these in turn. So personal habits. So one thing is you can just wear a sweater, wear a fleece in the house in the wintertime and reduce the temperature on your thermostat. So just take it from wherever it is, bring it down a few degrees. You will find that after a while you get used to it. And you know what? It saves huge amounts of energy. And if everybody does that, it greatly extends the amount of time that we'll have energy. Uh, Basically about half of the energy your family uses is in heating and cooling, and so you can extend this a lot. Another thing you do is just get in the habit of turning off lights when you leave a room. Turn off the TV when you leave the room. It's very simple things you can do that have a big impact when everybody does it. And really, a huge one is choosing to use public transportation. It's available to us here in the Seoul area, and if we do that instead of driving a car, we save a tremendous amount of fossil fuel by doing that. So those things that you can just do as an individual to help the problem. Now, unfortunately, what happens is most people don't do this unless they are motivated to do this by some external force. And the way you do this is basically by making it economically advantageous to conserve and disadvantageous to not conserve. So one way of doing it is having a tiered billing system, which they do have here in Korea, which is a good idea, but it needs to be improved. So the idea is, well, you pay a certain amount up to an allocated amount of kilowatt hours that seems reasonable for a family to use. If you go beyond that, we're going to, maybe double what it costs you to use electricity, maybe double your entire bill. All right, that'll teach you. And if you go way beyond that, we're going to triple it, right? And so the thing is, they do this here in Korea, but there's no way of me knowing, like where I am at a given point in time. So this really would work if you have some sort of real time feedback where the power company is telling you this is where you are in the your energy usage, and if you can see that, then you can start making adjustments to your habits to try to avoid paying this extra amount. Another thing you can do is just increase the cost of driving. So if you make gasoline cost more, you make the toll roads more, then people start going, well, maybe it's not worth it to drive. Maybe I'll choose public transportation instead. And you can also subsidize public transportation and make it so that people feel that it's definitely economically advantageous to use it. So by doing this, you can encourage people to make the choices that they need to make if we're going to conserve what fossil fuels we still have. Now, another thing we do is just change our technologies a bit. So here's a classic example. So LED lights are now very commonplace here in Korea. When I was young, they didn't exist. When I was young, you had incandescent lights. Incandescent lights, basically what Thomas Edison invented, right? So 800 lumens of light would take 60 watts of power to produce. Uh, now, over time, we went through fluorescent lights, then we came up with LED lights. With LED lights, you only use 12 watts to make the same amount of light. So basically, you're talking 5 times less energy per light bulb. That's huge. You can also we're at the point now where we have smart home technology where if I can set up systems in my home that can tell if I'm in a room or not. If there's no one in the room, why are the lights on? Just you can have it so it turns the light off when you leave the room. It turns off the TV when you're not in the room. It turns down the power when you're not in the house. This is we're here technologically to do this. We just have to implement it. And again, the government could help us do that by subsidizing a transition from your current home structure to a smart home structure. I'm not going to worry about the smart glass right now. Electronic vehicles are a huge step forward in trying to conserve energy. So basically, what happens with an electric vehicle that's so important is they have very high efficiency. It's not that they don't pollute; they do. There's nothing coming out of the tailpipe, but there's still pollution needed in order to produce the electricity on which they run. But if you touch the hood of a gasoline engine, you're going to notice it's very hot. That's because 85 to 90% of the energy released by burning gasoline is just going into making the engine hot. And that's just terrible. With an electronic vehicle, that's not the case at all. Most of the energy is going to making the car go. And check this out, when you step on the gas in a regular car, you're basically taking the kinetic energy of that car and you're just causing friction in the brake pads, and it's just getting just dissipated as heat energy and just sent out into the environment. It's gone. But with an electronic vehicle, when you step on the gas, the kinetic energy of the car is just basically being used to recharge the battery. It basically is running the motor backwards, turning it into a generator and recharging the battery. But again, I have to stress, don't kid yourself. It's not like electric vehicles don't contribute to global warming and don't contribute to pollution. They do, because you start to burn coal to make the electricity in order to charge your car. So it's not like they don't pollute. The advantage of them is they're just hugely more efficient than an internal combustion car is. Now, there's a lot of people who are trying to push for hydrogen power, and there's nothing wrong with hydrogen power. We'll compare them. So the hydrogen fuel cells, basically, the idea is I'm going to take hydrogen and I'm going to put it through a cell membrane so that I'm basically liberating the electrons from the hydrogen, converting it to oxygen, converting it with oxygen to make water, but I'm not making it hot. So again, the idea is I'm not making it hot and I'm releasing that energy. We saw the same problem that you've got to produce the hydrogen. And to do that, you're going to have to use coal. You're going to make carbon dioxide. You're going to make pollution. So it doesn't stop that from happening. It just stops that from happening as much by improving efficiency. Now, let's just look at how this works. Okay, so petroleum, which we're currently using, gets about 25 miles to gallon. It's easier to find rather U.S. Measurements. Okay, so 25 miles to the gallon. And a typical car goes about 375 miles on a tank of gas. Now let's compare that to hydrogen. Well, hydrogen basically is about 3 times as efficient. So basically, you basically get the equivalent of 70 miles per gallon when you use hydrogen. Unfortunately, the cars go about half as far and you got to refill. And at this point, we really don't have a hydrogen refill infrastructure set up in any country that I know of. I know you can get it in the Seoul area, but if you were to drive to, say, Busan or off on a trip somewhere, you'd run out of it and you couldn't fill your car back up. It's kind of hard to bring hydrogen to your car when you're away from a spot. Okay, you can't exactly put it in a can. All right, but it could be done. It takes a change in our infrastructure. However, just look at electric vehicles. Electric vehicles have this advantage in that they have a vastly higher MPG, so more than double that of hydrogen. So they have tremendous fuel economy efficiencies, and they have ranges that are getting close to what you have for modern cars. And there's now an infrastructure in place for them. Now, the big drawback is the charging time is pretty long. I'm not sure what it is, but it's inconvenient compared to just pumping gas into a car. However, there's consideration of maybe having replaceable batteries for cars, or just improved ways of charging them. So there is a technological workaround for that. And so finally, let's talk about cogeneration. So cogeneration isn't what it sounds like. Okay, so basically, what cogeneration means is it's also known as combined heat and power, or CHP. And basically, what you're doing is you're improving the efficiency of our standard, coal-fired, nuclear-fired power generation facility, because what you're doing is, instead of just sending 60% of the energy off to the cooling tower, because basically 40% of it's coming out in terms of electrical power, 60% of it just goes here. The idea is, instead of sending it to the cooling towers, I'm going to send it to people's homes. And so the idea is, I can so basically, if I just use a power plant to create electricity, 60% of my energy is lost as heat in the cooling towers. With cogeneration, I'm still just generating 40% of the energy that goes in is coming out as power. However, I'm taking 52% of it, and I have these hot pipes. I'm just sending them out to people's homes, and I'm using it to heat people's homes. And that way, they don't have to buy electricity to heat their homes. And so, in that sense, I can change it from having a 60% loss to heat to only an 8% loss for heat. And that is gigantic. I mean, that right there can save us just enormous, enormous amounts of coal and natural gas and vastly, vastly extend the amount of time in which these reserves will last and really give us the opportunity to develop the alternative forms of energy that we're going to have to use if we're going to continue to exist as a society. Thanks for listening.